So yeah, I want to talk about this subject, World Wide Web domination. It's always a question how in Hex we can manage to get a bigger, how shall I say, market share, become rock stars basically, because that's what software development is really all about. Um, and I kind of want to talk about the web, if you will, as an attack vector to occupy the whole world. And I needed a subtitle, and I couldn't come up with one, so I tried to be funny. Here you go. You're welcome. And it's kind of picking up on a talk that was done 5 years ago by Nicolas, Plans for World Domination. And it was about Hex 3 and Hex 4, which were long in the future back then. So it's kind of funny that we're now in between those two. And at that time, we were already, certainly Nicolas was thinking about what can we do to, get there and what might happen. Yeah, the main question, I suppose, in all this thing is why do we actually bother making Hex more popular? Because there's many things, and intuitively there's just something to be said for social validation. Like when many other people do what you do, then there's a good chance that you're not being the crazy person in the room. Okay, that's nice. But you can try to deconstruct that into things that are more tangible, measurable, that means something. One of them, yeah? Oh, you don't hear me? Okay. Yeah, sure. So one of them is to somehow ensure that Hex will continue to exist. That's kind of what people are sometimes worried about. There's been predictions of doom 2 years ago. If we don't become mainstream now, then we will die out soon. So that's one thing, and the other thing that's kind of two sides of the same things. People who want to use Hex want to be able to find a job where they can do it, and companies that decide that Hex is the right solution for them want to be able to hire people. And that's, especially in Hex, this is particularly tricky because it targets so much stuff. Like, like if you hire a JavaScript developer, there's certain things that he will be doing, but others that he will be not. A Hex developer can be like all over the place. Like me and game development, we're not friends, for example. And yeah, and available jobs is like a big thing because, shortly after Nicolas' talk, I realized how depressed I was with ActionScript 3 and Adobe's lack of leadership. So I decided to commit to Haxe, and back at that time it was pretty hard to find stuff. So I kind of burned through my family's savings. Which were, I suppose, for clever things. But I think, well, nowadays we see things have gotten better, but they can get better still. We still need a lot more people so that the matching between what's needed and what talent is there, kind of works. And the last thing is we want to have an ecosystem to rely on. A lot of libraries that's there. We don't want every company to have to build its own stack and maintain it and all of that. And the last part is the bit that I suppose we can kind of control as programmers. And so, of course, we want to attract people, but I think it's quite interesting that we talk about how we can attract contributors specifically and not just people, because there's always a lot of talk when we're discussing about where the language should go is how will newcomers see it. And I think the question would be asked, how will newcomers see it that are actually willing to commit to the language? Because some people are just always like, oh, well, I can't use Hex before you add feature X or Y or stuff. And then you add it and, they still not using it for reasons. So yeah, that's the part I want to talk about, really. And I want to just compare a couple of things, like very roughly. Like I'm making averages here that make like no sense because it's all exponential anyway. But like if you compare, for example, NPM and Hexlib, you get like 5 orders of magnitude of difference. And the question is there something to learn from that? And if so, what? I'm going to try to propose a few ideas, but who knows? And so, yeah, talking about the web in itself, it's like an interesting platform. Like there's a lot of money in it. It's amazing to see how modern browsers just move forward and how many crazy new ideas pop up, and then they all die and wither, and new ideas come. So it's not all very set in stone. A lot of things are possible, and the bad parts is that even though modern browsers are really amazing pieces of software, I mean they still suck for many reasons, but they are quite amazing. There's a lot of other stuff that you just have to deal with when you're living in the web, and also a lot of the things that you see, they come and they just go. So everybody here know Bower or have heard of it? It's like this front-end package manager for JavaScript, and its life cycle is between the two talks. Like it was released the year that Nicolas gave his talk, and it was deprecated this year. Just saying, okay? And JavaScript, like, it still has a long way to go. So there's interesting ideas in ECMAScript 6, but it still doesn't have a type system, and it's not sure if it ever will. And they've added classes, and now they're discovering that they don't want to be using classes at all. And it's kind of So so then there's Haxe on the other hand, which also comes with its own kinds of problems. Like nobody really knows what it is. It's not really clear that you can use it for a web at all, even though I would think it's one of the best choices. There's not many libraries. Tooling is kind of and it takes really a long time to learn and to master. And there's like if you look, then there's no shortage of rants of people complaining because they struggle to understand some specific part of Haxe. And it's not particularly trendy. Like we don't do stuff. And so the good part is it's not trendy, right? Like you look, for example, at CoffeeScript, which is just this bag of party tricks for building JavaScript. It's like on a rough decline right now. I mean, there's a state of JavaScript which kind of tries to measure what people are using in the web, and CoffeeScript is like it's plummeting. Nobody actually cares so much. And the other nice part is that Haxe actually takes ages to master. I think this is an opportunity. Like you can learn a lot of stuff. And what's really quite interesting is like JavaScript is like just this small, like for example, let's take JavaScript. It's just this language. There's not so much to learn about except when true and false are equal or when they are not. And then to build anything, you're gonna have to pick a framework basically, or some such thing. And frameworks lock you in. They decide things. They compete over control. You cannot compose them. Like at some point, you're gonna realize something in your problem domain lies out of the solution domain of the framework, and you're just screwed. You're gonna have to go to the new thing. And then people go from Angular to React, and I don't know what the next thing will be, but we will know in 2 years. And so what's interesting about Haxe is because it's a language, and it's quite well designed, language features are orthogonal, so you can compose them. They do not lock you in. Like you can learn 2 years, you can learn from experience, I would say about 7 years about macros, but you can combine that with other stuff. It's not one or the other, and you can pick one, and you can learn about one thing, learn about the other thing, and they mix, and that's really really quite cool. And so yeah, compared to all this web stuff, TypeScript, Dart, I guess you heard about some of it. It's really mature, and it's kind of here to stay. I mean, I'm pretty sure we're not going to be rock stars in 10 years, but it's still going to be awesome. And one of the things is that I think is actually quite good is that Haxe libs are currently quite scarce. There's not so many libraries out there, and I think as much as it's a burden, it's also an opportunity to rethink things. Also through the prism of a language that is so much more powerful than most of the mainstream stuff, at least. So in theory, it's like a match made in heaven, I mean, there's this whole vast sea of people who desperately are longing for a good solution. And and we have all of that stuff. But somehow it's not taking off so much. So yeah, one of the reasons is actually people ask, like, can you do A in Haxe? Can you use React or this or that? And of course you can. There's this quote, I don't know, I think it's a joke from the 80s or something. But like if you're determined you can do everything in any language, the real question is, do you want that? Like you can write ActionScript 3 code, for example, in Haxe pretty fine. you don't have flash.utils describe type. You're gonna have to do some magic to do that. But basically, you can do the same thing. But what I'm saying is that often you don't wanna. You just don't know because you haven't considered the alternatives. And so there's one thing that's really quite interesting. Like in NME and OpenFL, we saw a huge success in replicating something that works well. I tried to make this point last year. Maybe I got it across better this time. So there's API. Everybody knows that there's workflow, and we implement it well. And during the 10 years that basically since NME exists, if I got you right, Adobe wasn't able to pull something similar off, but rather let Flash just fail. And but we can't rely on somebody else to kill their technology in this way and emulate the same APIs. I mean, this was magic, kind of. Okay, I mean it's bad for Flash, but we can't. It's not gonna happen. I don't think so. And of course, with Flash being now like it was the final nail in the coffin, I guess, this year. So it's clear that also we must find other target groups to be appealing to, So one thing I always like to think about is Ruby on Rails and the impact it had on popularizing Ruby, because Ruby was such language not so different from ours in that there was very little corporate backing and all this kind of stuff, and instead in a niche for a long time. And although it has some really nice design decisions, it's untyped, so I don't care. But okay. And so what they did, what they did not do is implement JSP in Ruby, or something like that, or ASP.NET, or all these kind of enterprise frameworks. But they came up with something that was kind of fun to use and productive, and you would do the same thing that you would do before, but you would do it faster. And I think, you correct me if I'm wrong, but if you develop for OpenFL right now, you're not going to be faster than you are if you wrote ActionScript for Flash before. It's roughly the same thing. Like nothing really happens. It's just arbitrary things in the technology landscape, force you one way or the other, but you're doing the same thing. And another thing, 5 years ago, somebody had said that Node.js or that JavaScript is going to be dominating everything. I would have laughed, but yet here we are. And I think it's actually quite interesting how it managed to do that. I think one of the reasons is that it managed to take front-end ideas like non-blocking I/O and all this kind of stuff and single-threadedness, and put that on the server and give you something that's massively concurrent, and you can do like really, really great stuff that would be slow with how web development was approached before that, like server-side. There's this one language thing, of course, although it seems that in itself is not necessarily a way to dominate the world. And I think what also drove it is that it brought this real-time communication to the WebSockets and all this kind of stuff. So I don't think we can necessarily do the later because it's something really technical. But for the first part, because we have a language that is so wide, there's many approaches. And I think if we can find ways to transplant approaches from one and put it in the other, we might pull off something like that. But yeah, that's just maybe. And so I want to show a little project that I've been working on for the past years that kind of shows allows you to step in the mind of what a web developer does to Haxe if he tries to make it like to leverage it fully to build something that could be that way. I mean, it's obviously nobody heard of this, but it could work similarly. And so where do I have this? Okay. So basically, ThinkWeb it has this kind of idea. Is this big enough? No, it's not big enough. Yes, this is better. Okay, so it's basically this way to define interfaces for stuff, for web services, if you will, with normal Haxe types. So in this case, we use interfaces, and this is the API of GitHub, basically. I mean, it's a subset of it because, yeah. And So you can, for example, say at the root of GitHub are two so-called subroutes. One is to gist, which is to your own gists when you're a logged in user, and you can get users like so and all this kind of stuff. And then you can look into the subroute. So you can say, for example, it's possible to get all your gists since some point, and you can, for example, say that the since parameter is going to be in the query and all this kind of stuff. And what's quite interesting from that, you can basically, let's go here. Oh yeah, let's do this bit. So if we call this now and my connection is stable enough, okay. And I don't have, yeah. So what we're doing, like here, I'm setting up a connection to GitHub, and then I'm just saying, create me a public gist with the description. This is a test. I say, let it be hello world, and then let's hope that this actually works. Okay, and so this file basically just got created 20 seconds ago. Okay, and at no point did I have to touch HTTP or anything of that kind. I just declare this. I say where the parameters go. I can do all this kind of stuff. And because it's all driven by metadata, you can, well, and it doesn't necessarily work this way around, but for clients it's like really good. You just hide the abstraction layer. And there's, you can do the converse. So for example, here's a really bad server application. So this just, it's just all kinds of variants of hello world. It also has routing where you can pick methods based on whether some parameter exists or not, because that's how people built APIs in the olden days. And you may want to, connect to something that has been written with PHP 3 and it's just horrible, but you still can. It will solve all these weird issues. But you can do it the other way around. You can actually implement those things. Like you can also use these annotations on classes that you implement, or you can have the annotations on an interface and then implement the classes. Like I could go and say implements GitHub, and at the point that the compiler stops complaining about missing fields, I'm going to have implemented a GitHub service, as complete as this definition is. Okay, and so now if we run this, so there's one kind of interesting part about that, I would say. If we fire this up, so we have a server. There's nothing particularly interesting about that. Okay, it's running. So yeah. So for example, this tells me hello Haxe, or I don't know, Haxe. And there's two nice parts about this. One is so I don't have to worry, like in the method body, you're never gonna find somebody accessing, okay, look into the request, get me the get parameters, get me the post parameters, get me all that stuff. Like the actual business logic in the code is not tied to HTTP at all. This comes from outside. If you had the annotations on an interface, you would have an implementation that does not depend on this. You can move this application. There's another thing done by Kevin, which for example allows you to annotate stuff so it can be used by the command line. You have the same application, it will work the same on both environments. And then what you can do, for example, is also, so this returns data, right? It's just a message, hello world, and then you can say, for example, if it's requested as HTML, then I want to render it with some template function, which is very simple. It's the thing we see here, which is why this is such a beautiful heading. And but if we were not to do that, and this is something like, quite interestingly, where did I put this? Okay. Many frameworks do not really, okay, I already did this, but let's redo it. If you say that I want to have the thing as JSON, for example, then it's going to be done for you. There's this thing called content negotiation in HTML. Nobody uses it, but it's really quite awesome. Like you can have APIs and web applications right at the same thing, and the client actually controls what it wants to see. And I don't know of any framework that actually properly offers this, or I mean, they are equally obscure as this one. Let's put it that way. Okay, so you can do all this kind of stuff, and I think it's pretty awesome. And if you think about how would you do that in another language, you would kind of begin to struggle. Like especially PHP or something might not be the best choice. And yeah, the cool thing is like you can define this API and you can call to some other endpoint. You can use this like Haxe remoting, but with JSON or other stuff. So there's pluggable formats. It also works with form encoded data, so it doesn't matter whether you post JSON objects or post a form, it will figure it out and all this kind of stuff. So yeah, so that's pretty neat. It's not the new Rails, unfortunately, but yeah. And so there's this other thing that I do that people always mock me for. I like building big dependency graphs. And I think it kind of matters, because if you look at how NPM works, it's that. I mean, there's this, I don't know, 2 years ago there was this big thing where somebody removed right pad or something, and everything exploded in JavaScript. But I still think to some extent it's the right thing to do if we want to build an ecosystem, because it allows us not to have so much duplication. Like you can look at so many, so much of the stuff that exists, it always comes with its own, things, and they're always implemented, and they solve one corner case right, but you can't really mix and match all of these things. So I'm just going to browse through this stuff really quick. So there's Team Core, so there's, so it has this any type, which is now in the standard library and all this kind of stuff. So there's just kind of fun things happening in there. It has promises and futures if you're interested in asynchronous programming, but they are kind of better than the JavaScript thing because they are cancelable, they are lazy, and you can tell whether a thing is going to fail or not. If in JavaScript you do catch error on a promise, it's still a promise. You don't know that the thing is not going to fail. If in Tinkerbell you do recover on a promise, you're going to get back a future. Like, future is something that's going to happen, promise that, somebody promised. So that's hence the name. Maybe not very canonical, but yeah. That's what I mean by specific. So there's this other thing, okay, that's just for dealing with binary data. You can put it together, you can create slices all at constant cost. And it has a standard iterator for idiomatic hex use and a cursor that can, seek forward, backward, and give you smaller bits, like if you need to parse this thing. Because internally it's a tree, so its random access is going to be quite expensive. Then there's streams. So this is something that seems really unique to me. I haven't seen that anywhere else. I did this because I was so frustrated with Node.js streams. So in Node.js, for example, on a stream, like if you set the encoding to something, then the data that comes out are strings. And if you don't, then it's buffers. And there's just no way to capture this in a type system. So that's why I started thinking about the thing, and then it just became weird. But so they are immutable, lazy, and asynchronous, like streams would be, like streams of data. And you can filter them, map them, you can concat two streams and all this kind of stuff. And at some point you're gonna iterate on the whole thing, and it's not going to destroy the stream. Rather, when you stop, you get the rest of the stream. But if you hold on to the beginning, then you still have it. Game developers are going to go, because there's all this kind of stuff that should be cleaned up by the garbage collector, and who knows if it does that. Turns out on Node.js it's working really well. And there's also this distinction I have everywhere in the Ting stack. There's ideal versus real streams. Ideal streams can fail, real streams cannot. Well, it's obviously opposite. Okay, and so basically just to give you an understanding, so everybody knows the linked list, all right? So you have one thing and it connects to the next. And so, yeah, let's just make this arrow be asynchronous and lazy. It's just so fitting that Tinkerbell promises and futures give us both. And so, yeah, suddenly it's a stream. Like, you can start iterating, you can stop here, and you have the rest of the stream and all this kind of stuff. And it works pretty well. That's not how it's implemented, but if we were to look at it, for example, this is how we would make such a stream from an iterator. I mean, sorry, it's just declared this way. It's a feature of a pair of a T and the rest of a stream. Becomes a bit functional, but okay. And you can make this from an int iterator or stuff like that. And you can, do all this iteration. And the iteration function also looks actually pretty easy if you're used to functional code anyway. But this stuff is relatively easy to conceive. It's relatively easy to check in a language like Haxe, but if you don't have a type system, it's going to kill you. So yeah, you can go on. So I/O is about, well, I/O. So you just say a source where data comes in is a stream of these chunks that we had. You know, generic programming. Yay. Sync is just something that can consume a stream. So it could be a parser, it could be standard out, all this kind of stuff. And because it's the syncs that drive I/O, there's the back pressure propagates nicely. Like a problem that you have in Node is basically you have data coming out from the outside, and it's not clear whether the server should already accept it or not, because it's all event-based and it's not really like the flow of stuff is not really clear, and you might wind up breaking quite easily to the 2 gig barrier that you have in your server, because you just let data come in, and at some other point you're going to decide to write it out. But whatever your output is might be too slow, and then you're kind of screwed. And yeah, the way it works here, it's actually the data is pulled through your server, so you get really good bandwidth. Latency is not optimal, but nah, okay. And so it turns out that on Node it's actually kind of better than the native thingy. I tried piping like a 500 megabyte file from one file, well, to the next location. And by default it uses half the memory and is 10 to 20% slower. And you can triple the chunk size or something, and then it starts getting faster than Node. But at some point, of course, it consumes also more memory. But it's kind of interesting because I have no idea how Node streams work, and this stuff is built on top, and somehow pipes better. And yeah, I mean, I never was into I/O, but with Haxe, this kind of became fun. So there's, yeah, boring stuff, URL handling, all those kind of stuff. HTTP, that's actually quite interesting. That's what's running under ThinkWeb. So this is a cross-platform abstraction for streaming binary HTTP. It works on almost any platform now, I think. And it just has 2 parts. So a handler is something that takes an incoming request and produces a future outgoing response. This is, okay, it seems kind of obvious. And you might see a client is something different, because actually on the client you make a request, but you may get a response or not. This is why we have a promise here. And this is the universal abstraction for building a server application. And what's really nice about this, all this stuff is technically pure. I mean, it doesn't have to be, but it could be, and you can test the whole app as a function without ever shooting up a server. You know, you can just create these requests and call a function. And there's ways to construct a client that actually always talks just to a handler directly, for example, if you want to make a more integrated test but still don't want to be having a server. So yeah, so that's cool. This probably won't interest most of you, but if you really want to do weird stuff with macros, hey. So this is, yeah, type crawler is rocket science, like when you have big data structures and you want to construct stuff for them. So, for example, there's a validation in the clone library, which, like, for example, the validation library creates a validator that can check at runtime without any reflection whether a value actually confirms to a certain structure. And, you know, all that code is just generated. Like, for example, when you have type defs, then this stuff melts away at runtime. But this way you can check that if you get an object, all the fields are there, they have the right types, all this kind of stuff. You write almost no code. That's actually Kevin who created that, not me. So yeah, but there's, for example, query string, which also uses a type crawler. So it can just take this kind of stuff, transform it into a query string, or parse it back, and it works just fine. And it works on an iterator of any key value pass. So you can also use this for validating forms or stuff like that. So you can get a node list of any element that has a name attribute, and you have to do some extra to, you know, get this kind of iterator. But then you can just validate forms like so. So this is, for example, the test for the library. You just declare what a password is, what an email is, what sign-up data is, and then you can just do things like create a new form of sign-up data, call validate on it, and you're going to get a validation result. And it's just going to tell you which elements are wrong, and then you can apply CSS classes to them or whatever it is that you want. So yeah, how do I? This is how. I'm sorry, I'm totally over time. So there's think.json, which also uses type crawler. So this generates parsers and generators at compile time, also fully reflection free. So this is cool. Like, for example, you can completely obfuscate your code and it will still parse the JSON just right. It validates while parsing. So for example, if somewhere there's an int, but it should be a string, it will tell you that, and it will point it to the source. It's not like you're traversing the object tree after the fact, and then you don't really know anymore where this stuff came from. It just, it does it while parsing. It supports plugin custom parsers because we have all the type information in the world, so why not? And it's actually quite fast. Last year I already talked about this. It was on Node.js, for example, it was 3 times faster for writing. It was half as fast for parsing as the native thing. Then Dan told me that actually if you use Simon's new analyzer, it's actually even faster for parsing than the native stuff. But then later he told me if you use it on real world data, then it doesn't work that way. So yeah, write your own benchmark. And so yeah, and TigWeb puts all of this together. So I think it's 12 libraries in total, but they only come in at 8.7 thousand lines of code, which I think is quite okay. I wish everything were that lightweight. So yeah, and there's this, no, but I'm totally over time. Okay, so there's all this stuff so this library I've been working on, it's called Coconut. It's kind of like React for Haxe. It's fully type safe and all this kind of stuff, and it, through React Native, it can actually render to native things. So yeah, this is the HTML version of the beloved. Where is this? Okay, now my internet is breaking down. No, okay. Everybody know this one, right? And you can work on all this. Yeah, everybody knows that application. And just to show that real quick, we don't need this. Yeah, goodbye. So this is the actual thing. And so it does, like, unfortunately there's no syntax highlighting yet, and it's all in string literals, but there's an ongoing discussion about all this. But what's really cool is, for example, if you mistype something here, then it will hopefully tell you, yeah, that the attribute is wrong and all this kind of stuff. Because what this actually boils down to is function calls. So the compiler actually does all the type checking. Like span is just really a nice syntax for something like span. And here go you can even see the auto-completion. Great, isn't it? Okay, and it does all that plus a couple of extras. And what's nice about the extras is that it has insanely well-working data binding. I never expected that to happen. But you just write things down this way. So you say, for example, if there's any items, then render this stuff. At the end, it all goes through a VDOM differ. So that also helps not actually touching the DOM. That's nothing I wrote. It's just some other library. And it does all this kind of stuff. But I don't really have time to show it all in detail. I will show one thing, which is kind of fun. I always like that. So this is how you would, for example, instantiate a list. And filter is basically what tells us which to-dos we're looking at. And to-dos is the actual list that has the data. So if we compile it this way, you can fire up the thing. No, I actually need to. Is this the right one? No, it's not. Then this could be the right one. No, that's also not the right one. Okay. This is the right one. Okay, so now we have 2 to-do lists, but as we can see, like, they are completely wired up. But the filters are independent. So, I mean, it's not like in React, if anyone knows React, that you have a global store or stuff like that. You can just really put objects together, and it's based on the idea of having truly observable objects and a really good cache layer between those and your view. And so yeah, it works pretty well. We're kind of deploying that at Dockler right now. And so far people tend to like it, although sometimes they are also amazed that it works. So yeah, so this can be fun. So there's going to be a workshop on this later this week where I can go into the details. So this of course has a proper dependency graph, as it should have. So yeah, but the question is, how do you do that? And with Hexlib really isn't the answer for that. And so I made a triad of tools that kind of address this. One is for abstracting away stuff in the compiler that I don't really like. One is for switching hex versions, and one is for installing packages. So basically, in any project, all dependencies are always locked and tracked. And the compiler, unlike it does it now, does not require the package manager to resolve libraries. That's just a clear convention. That's how Node does it. Like, Node.js does not rely on NPM. NPM happens to install packages where Node would expect them, but that's it. And right now these things are coupled, and because Hexlib, well, all the people I know who worked on it, and I did too, think it's horrible, and it's not clear how to fix that somehow. I mean, maybe nobody tried hard enough, but it's not evident that you can. So yeah, and metadata and data don't go into the same place, and there's no new configuration format introduced. Like, for example, we can look at the to-do MVC here, and what actually happens is that you have this hex library folder, which contains all of the stuff in plain XML. So it has class paths and defines and all this kind of stuff that Hexlib usually has to figure out for the compiler every time you compile, and it's. If you have 50 dependencies, then actually Hexlib runs for half a second. And it also, the package manager leaves behind an instruction how to reinstall that thing if it's missing. So you can check out this project everywhere you can run it, and you can just clone, you can just run Lix install, and it will download all the right things. It will also install the right hex version that you have configured for this project to run in. So the project setup with this stuff is frozen in time, without actually shipping the dependencies, and you can restore it anywhere. That's really helpful, because with all the dependencies I have, I often break things, and I don't want a Hexlib update to just, destroy all my work, basically. There's a honorable mention. Anybody heard of Travix? Okay, so that's pretty cool. That's for people like me who are too stupid and impatient to deal with CI. So that's basically a library where you just go Hexlib run Travix in it, and it will take your project and make it Travix ready, and it will ask you which platforms you want to test it on and all this kind of stuff. And when it runs them, it does this tricky thing where it actually installs heavy things before the test is run. So like if you forget a semicolon or something, you don't have to wait for C++ and the Java runtime and everything to install and then tell you, sorry, you're missing a semicolon. You're first going to test it on the interpreter, and if that passes, then your C++ tests are going to. So you know within 20 seconds, maybe, hopefully. And special thanks to Kevin and Andreas, who couldn't make it, and Sebastian, who I'm not sure is there. But they took care of all this kind of stuff, like making it work on Lua and making it work with Flash and PHP 7 and all this kind of stuff. So the only thing that doesn't work is HL, I think. But nobody knows how it works. And yeah, I think one of the things I think I tried to touch on earlier is to realize what our strengths are in Haxe. And I think it's okay to accept that we're not necessarily having the best tool for beginners. I mean, there's people who focus on that, and they do that really well. And I'm not sure if there's not more to be said to just make it better for the people whom Haxe is appealing to, because right now, or recently, we had quite a lot of people who've been with Haxe for a long time leave, which was kind of unexpected, for me at least. It was a bit of a shock. And this probably should not happen, because those are the people that we want to keep around, I think. One of the last problems, I think, that's kind of... One? Well, you're not listed in the Haxe evolution process, but okay, maybe that can change. So yeah, something should happen about that. I don't really know what it is. I don't like committees or anything. I don't want to propose myself or any such thing. On the other hand, yeah. Well, anyway, you're doing a great job anyway, but try to understand that there's completely weird people too that just work on different problems. And I think there's one thing that we should really start reconsidering for Hex 4, because is this batteries included thing that we have really so good? Is it going to scale up? Does it, like, I don't, for example, work much on the standard library because I know that my patches are going to ship in a year or something, you know. And that's yeah. So we like, it doesn't fit with the 12 backends that we have now. I understand why our releases are so far apart, but you know, then if on the other hand you have all this kind of stuff crammed in, it becomes hard to do things. And I like OCaml scares the shit out of me, but there's stuff I could be fixing outside the compiler. So yeah, let's save the web together and maybe try this way or another. Okay, I guess that's it. Okay, those who are hungry, go eat. If anybody has questions, you can ask, or you can ask me over a sandwich. Simon.
Yeah, about the whole HexLib situation. If I were to say, like, we're moving to Hex 4 now, let's just dump HexLib and use your tools instead.
Yeah.
Would that be an option?
It might be an option. There's really 3 parts. I'm not sure we want to have the middle one. Like, do we want Hex to also deal with concurrent Hex versions? That's an interesting, but anyway. And what Hexship really does is it calls the Hex compiler with almost all the arguments. It only resolves lib parameters following a simple convention. And I think we should build that into the compiler. And then we can have a war of package managers who are going to... or anything. It's usable, but it relies on Node.js right now. I guess that could be fixed. I wanted that because, like, Hex C++ installs from HexLib about 2 to 3 times as fast because it's being unpacked while it's downloaded, which is stuff that you can not really do in Nico so nicely. But yeah, you could make a slower version of the package manager on Nico. But I didn't want to commit to Nico because I don't even know if it's going to exist in 5 years. So yeah. And you can make it with the interpreter because in the package manager you want to have HTTPS, and I don't think we're going to do SSL into the compiler. So yeah, Node for now is the best choice, but we can discuss it. You know, I mean, it's ready to use, and there's like, yeah, there's a handful of very brave people who use it, and they love it a lot just because of the reliability it has. There's a couple of features missing, but you know, I think this is something like this is the way forward, and this will work.
So yes.
Yes, Philippe.
Yeah. Did you check HMM?
Yes, I did.
Yeah. What do you think in comparison with?
It's kind of okay, but the thing is, HMM works with HexLib local repo, for one.
So you use it, yeah. It uses .axlib to.
Yeah, exactly. So for every project that you have, it installs all the libraries, and Lix doesn't do that.
Yeah, that's something that could be solved because.
Yeah, sure.
I mean,
It's just I don't think HexLib is a good basis to build on anything. So that's why I didn't go with that. And also, HMM does not lock stuff by default, I think.
it can.
It can, but you know, this should not be optional, at least for me. I mean, I just started with the approach, I want things to be entirely reliable and there, and in the beginning there was just this convention about how you configure libraries, and I would edit this HexLib files by hand, and they would point to Git submodules and stuff like that. But this was like, but it was so much better than HexLib, like seriously. I'm sorry. So yeah, yes, I've seen HMM. I didn't follow that line.
Yeah, I think you're unfair. It's a good solution, and I added blocking recently.
Yeah, I saw that. Yeah.
So that's and the .axlib kind of makes sense, and you don't have to. So you still have the Axlib resolution, but it's using the local one. So it's.
Yeah, but the thing is, I don't necessarily want to be having OpenFL or Hex C++ like 50 times on my machine.
Yeah, but you don't have to. The .axlib doesn't. I mean, if the problem of .axlib is that it duplicates the libraries, that is solvable depending on the within just the Axlib client?
Yeah, we've talked about it, and we didn't do it. You know, I mean, basically the stuff that I built here, I proposed to Nicolas and Simon, I think 3 or 4 years ago, and they said, well, Simon said it's really hard, and Nicolas said, don't touch this, you're just going to break everything. So yeah, I tried to build something next to it, and maybe we should dump it and move forward with HMM. Okay, maybe, I don't know. For me, it was important to show that, you know, it can work really well this way, and I'm happy with how it came out, and then we can, you know, we can look for a way forward. Okay, any more questions? Then off to lunch.